Alright, so here is the periodic table chapter in your chemistry class. And again, there is a chapter in your book. It starts on page 154, and it's called the periodic table. There are some video clips that you can watch. We're not going to watch them actually in the notes section, but you can watch them. They'll be attached to a couple different things. So what we're going to look at in this section is just general history, so a couple of people that have really contributed to the periodic table, and just kind of how is the periodic table set up. And if you look in your book, real text starts on page 155. You really want to notice that the periodic table is just searching for an order. So what happened is we started discovering lots of elements, and when you start getting lots of things, they become cumbersome if you don't have them organized. So the periodic table that we use is basically what most chemists consider the simplest, and it shows us the most trends. But really what they were just looking for is how can we take these things and organize them. So the first guy is given any credit for really organizing things was Johann Dobereiner. He's also in your book. And he came up with this idea that you could organize some of the elements in these things called triads. And one thing to keep in mind at the time was there really were only 30 elements at the time. So it wasn't as big of a deal as it is maybe today, where you have like 118, 119 elements. But what he did see was there was a trend where if you look at these guys, calcium, strontium, and barium, if he took their molar masses and he averaged them, what he saw is that the average was right about in the middle. And again, this is back in like 1817 when he started working on it. In 1829 is when he published this. So, I mean, we're not talking sophisticated scales, but what they saw is chlorine, bromine, iodine had one that was similar, and sulfur, selenium, and tellurium was similar. What we know today is these elements are in the same family on the periodic table. At the time, they didn't know about families or anything, so this was kind of the first step. There was a guy named John Newlands who, in 1866, so about 30 years later, he noticed that, again, there was a pattern, and he saw that about every 8 elements, typically things repeated, and he saw that these elements acted similarly, not the same, but similarly, and he called it the law of octaves because of the 8 things like in music. At the bottom here, you don't have to write this down, but just so you know, there was an International Congress of Chemists, and that was when they actually standardized atomic mass, so different countries you could actually converse scientifically now. So that was helpful to science. And again, this is about 30 years after Dobereiner, and now we're up to 60 elements. The next guy we're going to talk about is probably the most famous for the periodic table. His name is Dmitry Mendeleev. He is a Russian chemist and teacher, and he came up with the actual first formal periodic table. And when you read your book, which you'll do later in this chapter, or you can do it at night, he actually has the periodic table in there. So basically there's a couple things that he was really good or given credit for. So he organized the elements in order of atomic mass, so like smallest mass to largest mass. He noticed that there were similar properties, and what he also did, he noticed that there were inconsistencies. So if you put things in order, he noticed that cobalt and nickel seemed to be in the wrong place. They seemed to be swapped. Tellurium and iodine seem to be swapped, and argon and potassium. So he said there's something that we're not seeing, and he noticed them, but at the time he didn't really have an answer. Probably his biggest thing that they say he's famous for is he actually predicted the existence of elements. So what he said was that, hey, there's this spot that there's nothing really that fits in, and it's not that there's something wrong with the periodic table. It's not that we're not doing something correctly. It's really just that we haven't actually discovered the elements yet. It kind of sounds funny today because we basically know all the elements that exist on Earth naturally, but at the time, for him, they were discovering lots of different elements. So it made more sense that, hey, there might be elements that we haven't, found yet. And one thing that's interesting is these are the 6 elements that he's given credit for: scandium, gallium, germanium, technetium, rhenium, and polonium. And what's interesting is technetium is not found on Earth. So he predicted the existence of an element that he could never actually find, which I think is pretty interesting. If you want to look up a cool element, technetium is pretty cool. When he predicted them, he called them Eka aluminum or Eka silicon. That means below. So if you look below aluminum, that's where you find gallium. And if you look below silicon, that's where you find germanium. And he didn't just predict like they existed. He predicted what they would look like, what their molar masses were, what their densities would be, what they would react with, what they would, how reactive they would be. So he's given a lot of credit for that prediction. Couple other things he did is he came up with his first periodic law, which basically just stated how did he organize the periodic table. And you want to notice that he did it by atomic mass. We don't do it by atomic mass anymore. That's why it's called the first periodic law. But that's what he did. And he is known as the father of the periodic table, so you should know that. A couple of things down here just about him. And there's some more information in your book about him as well. He wasn't actually that famous during his lifetime. He was a respected chemist, but he wasn't like Albert Einstein or anything. He did not win a Nobel Prize. He was nominated, but he lost. And once you are deceased, you cannot win a Nobel Prize. It's not part of the rules. But he does have his very own element 101. And then the last guy that we're really talking about with history is good old Henry Moseley. And what he did is he tweaked Mendeleev's periodic table. So he was actually, and he was very young. And what he was doing is he was kind of just going through and checking other people's work. And what he found was that there was the nuclear charge of atoms. So if you remember from the atom chapter, he figured out the atomic number is a proton, or how many protons. So what he said is really the periodic table shouldn't be based on mass necessarily. He said it should be based on protons or your atomic number. So if you do that to Mendeleev's periodic table, what it does is it fixes those inconsistencies that he saw. So Mendeleev originally disagreed with him. He was kind of like, didn't think that was the right way to go, but he was not correct, and Moseley was. So that's what Moseley is given credit for. So you should know Johann Dobereiner. You should know John Newlands. You definitely want to know Dmitri Mendeleev, and the last guy you should know with the periodic table is Henry Moseley. And like I said, there's about 3 or 4 pages in your book on it, which is very simple.